Static friction. In this module, you will learn about static friction. Look at this insect crawling up a hemispherical surface. It can crawl only up to a certain height. After crawling up to that height, it slides down. Why? We'll find the answer for this in this module. If we place a block on an inclined plane, it does not move or slide down if the inclination theta is less than a certain value. This is because of the force of static friction equals mg sine theta. We can represent various forces acting on the block. The weight of the body mg acts vertically downwards. mg is resolved into two rectangular components, mg sine theta parallel to the plane and mg cos theta perpendicular to the inclined plane. The component mg cos theta balances the normal reaction N, and the mg sine theta balances the frictional force. The force of static friction is given by Fs is equal to mg sine theta. On increasing the angle of inclination theta, the right-hand side of this equation increases, and so does Fs. Since Fs increases with theta, we can say that the force of static friction is a self-adjusting force. However, there is a limiting value of Fs beyond which it cannot increase any further. This value is given by Fs is equal to nu s m, where nu s is the coefficient of static friction and m is the normal force. In this example, let theta 0 be the maximum inclination for which the block is stationary. Then mu sn equal to mg sine theta 0, mu s mg cos theta 0 is equal to mg sine theta 0, which makes it mu s is equal to tan theta 0. Theta 0 is called the angle of repose. Look at these two scenarios. Both are identical, except that in one case there is no friction, while in the other there is. When there is no friction, the cylinder does not roll, it slides down. When there is friction, it makes the cylinder roll down. When an object rolls down an inclined plane, does the force of static friction do any work? Let us examine. Suppose an object descends through a height h as it rolls down an inclined plane. The loss in potential energy delta U is equal to mgh. This loss in potential energy gets converted into kinetic energy of the object. However, kinetic energy itself has two forms: translational kinetic energy and rotational kinetic energy. Delta K is equal to half mv square plus half I omega square, where I is the moment of inertia and omega is the angular velocity of rotation of the cylinder. Since it is static friction that causes the rotation, the work done by the force of static friction is equal to the gain in rotational kinetic energy. Ws is equal to half I omega square. In this module you have learnt the insect crawls up the surface till the inclination of the surface is less than the angle of repose. Beyond that, it slides down. If an object in contact with another surface remains stationary due to static friction, we say that the work done by the force of static friction is zero. On the other hand, if an object rolls down an incline, we can say that the work done by the force of static friction is equal to the gain in rotational kinetic energy.